right, so we just heard from Lauren and Matt. We talked about different ways that we could factor, and there's also another way, and we can use the AC method. In high school and middle school, if you take Algebra 1 in middle school, you learn how to factor a little bit, and as you get higher up in like in Algebra 2, you start learning different ways to factor. For me, when we started introducing different coefficients in front of the x squared that weren't 1, it almost was too much for me to think about it, trying to figure out which went where. It was a lot to process. Do you think that all students feel this way?
Probably not all, but I think a good majority probably does.
To some extent.
To some extent. Do you think that, like me, it's a lot to think about in one
It's a lot to put in one problem, yeah.
Yeah, definitely. So, this is the AC method. This is going to help. This is a way to help students kind of organize their work to make it a little easier to go through the steps of factoring. So yeah, Dr. Cochner, who wrote the article, she just pointed out that yes, it is difficult for some students. However, there is hope in the fact that there are different techniques that can be used to provide structure while trying to grasp the skill of factoring. So it doesn't have to be hard. Like you can help your students in any way you can. So for the AC method, this is our theorem. You have ax squared plus bx plus c is factorable if there exist integers m and n, such that m times n equals a times c, and m plus n equals b. Right. Okay? So we're going to look at this trinomial below and work through this together using this theorem to show how it works. Okay? So first, let's write m n down, and we know that m times n has to be what?
Equals a times c.
So what is 24 times negative 6? I wrote this down.
144.
Yes.
Negative 144.
And then plus n has to equal what?
B.
Which is?
Negative 7.
All right. Now, let's make a table with the products and the sums. I like using the table because it's easier for me to see all of the products that give us 144 instead of just trying to think of all the different ones in my head. So can you think of a couple?
12 and 12. Negative 12. Negative 12.
And what is the sum of negative 12 and 12?
0.
And let's see, then there's 1 and 4. Either one of these. And then that's just, so that doesn't work.
143.
We're at 39. Just ignore me. Okay, I said 11 minus 8 was like 5 the other day. It was just okay. So we know that negative 143 is not negative 7. So we think of two other numbers that would maybe the sum would be closer to negative 7.
I can't think of that.
Yeah.
44. Okay, let's look at 8. Let's 8 and
18.
does that work?
No.
Closer.
It's closer. Okay, so let's look at 9 and
16.
does that work?
Yes.
All right, so here we have our m and our n. So we're going to take these two products and we're going to put them in place of negative 7x. So we're going to have 24x squared minus 16x plus 9x minus we're substituting these two values in for 7x. We still get 7x if we combine these two together. Okay. So let's group these guys together. There's a plus for you. So do you see a common factor in 24x squared and 16x?
8x.
Okay, what about 9x and 6? 3. Okay, so what do you think we would do next?
Well, the linear terms in the parentheses are the same.
Are
Is there
they?
anything?
Yeah.
You can factor out the 3x minus 2 out of that whole sum.
I did not. No. I clicked on pen with knives. So we could have done it this way, or was there another way we could have?
That's the way I know how to do it. I don't know.
You don't know? No. Hold up just a second. I'm missing something. So does this look like factors?
Mhm.
Yeah.
So if we were to distribute these out, multiply them together, do you think we would get the correct?
I don't know, let's try it.
Let's try it. Okay.
I have a
What is-
question.
Yes.
Why did you put those parentheses around that 3x minus 2? We stood there and looked at it for a long time, when it was 3x minus 2 times 8x plus 3, and the other students in the class seemed to be okay. So, and then you wrote these parentheses there, and no one has said anything about why.
Well, I put them in parentheses here to show that it wasn't just the 2 being distributed to the 8x plus 3. It needed to be the whole 3x minus 2. So it was important to have the parentheses there.
Yeah, I figured that's what you were waiting for, but they didn't say anything, so I didn't know if they actually.
We've never factored before.
Never factored.
You've never factored before. Okay.
This is high level if you haven't factored before.
Okay, so if we were to check this, here, I want to change the color, this is just important. Okay, so if we were to, okay, so what's 3x times 8x?
24x squared.
Look, that's the same as the first term.
Oh my gosh! And what about 3x times,
What's 9x?
is that a 3? That's what I know, it's a 3, it's just like a little rough. 9x. And then we're taking our negative 2 times the 8x is
Minus 16.
and negative 2 is 6. And so we have our m and n terms, but if we combine them, we get,
-7.
yes, our b term. No, not plus, just. And we have our answer, so we know that this right here works. Yes?
Yeah.
We're looking good?
Looking
Do
great.
y'all like this? Like this method?
Yep, that's how I learned it.
There you go.
For people who like formulas, this would be good.
I like formula. So let's look at another example. So we have, who wants to start? Lauren, you want to come up here and
This is
mention?
the last one.
Oh.
I got it.
Whoops.
I guess that was probably my responsibility since y'all these for long.
All right, so what are you going to do first? Simplify.
that. Okay, see me.
Yeah.
So.
A times C is
Move plus two.
huh?
And
M
plus
plus,
C.
there you go, M plus N equals 7.
B also equals 7, but
Oh.
I'm trying to find M plus 7.
So now what are we gonna do? Make a table.
So we can. Alright, so. 2:15.
Mhm.
So. Would you
Ooh.
look at that?
We found it! Yay! Okay, so now what did we do? Since we found our M and N variables.
Split the B. Split the B and
Split
the
the B
7.
and the 7x. So you're gonna write 2x squared and substitute in -3 and 10 in place of B. Because M plus N.
Okay.
So now what? Are we gonna group 2x together?
Oh, we pulled out the.
I would go ahead and put parentheses around here to show what you're grouping.
Okay.
So, there you go. Looking good. Any questions? I'm not done yet, but, oh, there's, we're gonna look at one more thing. Since we looked at trinomials with, a value of A that's not 1, we're gonna go ahead and look at what it would be for if we had a value of 1. So we have our M plus N equals -5, M times N equals -24. We also have, I'm just reading.
What did we do? 8 and 3.
8.
Negative 8.
Negative
And
8.
positive 3.
Place of E3. I was like, where are you getting that? Not equals. And then what next?
Put parentheses around x squared minus 8x. And around 3x minus 24. Out of the first one, take out a x. And then 2x minus 8. Plus. And then you gotta take out a 3. Minus 8.
So it still works for a trinomial with a coefficient of 1. And if we look at our theorem, M times N equals AC. When A is 1, it's just M times N equals C. So you can still use this, and it's just,
Why does it only equal C?
because when we have a coefficient of 1 for A, 1 times C is just going to be C. So M times C will equal C right here. And that's what we've been doing prior to this with factoring. Any questions?
We didn't applaud for Lauren, so we applaud for Lauren.